My name is Matt Yarbrough. I am one of the system engineers in the dotCMS support department, and I will be walking you through the essentials of dotCMS system administration. We're going to talk a little bit about the components that make up a dotCMS installation. First of all, dotCMS is a Java-based application server. It will run on pretty much any modern Java 1.8 or 1.9 implementation. We actively support, at this point, Oracle and OpenJDK. There are people using other JVMs that have had success. Our support department doesn't have training or background in those other JVMs. So if you're encountering problems that are JVM specific, we may or may not be able to help with those, but it is known to work just fine on others as well. It's sort of like the high level view. You have an architecture that will have a number of different dotCMS environments, and we'll come back to this diagram a couple times over the next 2 days. It's essential in understanding how different environments work together and how push publishing in particular can be best utilized. But we're going to get a little more detailed than that. We're going to get down into the actual components that make up a dotCMS installation itself, starting with you download the dotCMS application, and you will see that we have an application folder, which is what we'll always refer to as the dotCMS home. So if you're involved in a support ticket or asking for something in the dotCMS home folder, it's that folder where you unpack the dotCMS application. So in this case, my home folder, and we tend to use the standard Linux paradigm of putting our application under the opt folder, the vendor name of dotCMS. We put our files under the www root, and then whatever the name. The most common pattern is to call it the release number. So you might have dotCMS 5.0, dotCMS 5.1, etc. for each different release. In this case, this is a training VM that I've just set up. So I've got it set up as the training 5 node. We are training today on dotCMS 5, which is our upcoming release. I believe it's due to come out on Thursday. Within this application folder, there are a couple different folders. We'll go to those in a little more detail in just a minute. First, I want to talk about the components that make up a dotCMS instance. You have this application, which is running the Tomcat application server. We bundle Tomcat with our install. With the latest release, we are bundling Tomcat 8.5.32. For the most part, you can upgrade the embedded Tomcat if you have a need to do so. Jumping a major version is something you'd want to consult with dotCMS about before doing. But bumping a minor version, if you want to go to 8.5.36 or something, that should not be an issue. There are also going to be components that are here stored within this this application tree here, plugins. There's two types of plugins. We'll talk a lot about static plugins and very little about dynamic plugins. Dynamic plugins is more of a content architecture or developer topic that gets covered in those courses. I will talk a little about how to install them and where they go, but we don't really cover them in this course. Static plugins are custom code or configuration that needs to happen before dotCMS is fully started up. And those go here in the plugins folder. If you have an environment that's up and running, you encounter a problem, open a support ticket, we work with you on it, we discover that there's some sort of bug in the system. We issue a hotfix. that hotfix is going to go in this plugins folder. The hotfix is intended to supersede the original code that came with dotCMS. And when I talk about how we do plugin configuration, I'll get into that in a little more detail. So those are the things that are kept within the dotCMS application tree. The next level are things that by default are located in the dotCMS application tree, but do not have to be. Those are our local resources here, a little larger. So those local resources are things that are going to be unique to every dotCMS instance. You could have a cluster of 20 nodes of dotCMS instances. Each of them is going to have their own set of local resources. As we get into external tools, there can be exceptions to that, but as a general rule, you'll find your dotCMS cache and your dotCMS index are going to be local. They're going to be on the same device as the dotCMS or same server as the dotCMS installation. They don't need to be on the same partition, and in fact, it's a good idea to move these off to their own partition. An SSD partition, ideally, because you're going to get the best performance on an SSD partition. And both the cache and the index are very I/O sensitive. The more you can speed up their I/O, the better performance of your website. And we'll talk in more detail about both the cache and the index in a few minutes. The next level of resources in a dotCMS installation are what we call network resources. They don't have to be on a network. If you have a standalone dotCMS instance, if you're in your development environment, you've just got a single node and you've got your database on the same server and you've got your assets on the same server, that's fine. When you start looking at production environments, when you start looking at clusters, generally, these are not going to be local to your dotCMS install. They're going to be on a network share somewhere. So your database is going to be one of the supported databases, Oracle, MySQL, Postgres, Microsoft SQL. And we don't have a whole lot of guidelines on how to configure those. We have some basic things that need to be set up. They're in our documentation. Specifically about configuration of the database. We generally defer to the vendor guidelines as much as possible for the databases. We're not experts in any of them, so we don't want to try and present ourselves as knowing more than the vendor does. And the other object is what we call the asset store. The asset store is going to be items that are stored on the file system. It's not as I/O sensitive as your index and your cache, so it can be stored on magnetic storage and it's fine. It can be on an NFS share, that's fine, SAN device, whatever. It does, like the database, it has to be in the same data center. If you're wanting to talk about doing things and split across data centers, we get into push publishing. And I'll talk about that a little bit later. But you really want to keep your database and your assets local, local at the network level. They need to be within the same data center. Ideally, they should be in the same subnet, just to reduce the problems of connectivity and lag. So yeah, that's the best configuration for that. And I'll talk about this a bit more when we get into the index and the cache, but those cannot be on a network share. You can't put your index or your cache on an NFS. They can be on a SAN device because the file system or the operating system sees that as local, and it gets I/O priority. A network device, you're going to have enough lag on your index and on your cache that it's going to really bog down dotCMS. And could even cause it to crash because they're very bound by I/O. So we'll talk a little bit about these assets. By default, the assets, the index, the cache, all live under the .secure folder. oops. Which is under Tomcat Web Apps root.secure. In most cases, we recommend moving that .secure folder out of the .cms application tree. If you're going to put your cache and your index on an SSD device, it's easiest to move these out of that folder and just put a soft link to them. Or there's a configuration setting that we can use, and I'll talk about that in a minute. And it makes it easier to do things like backups and restores if you've separated out your application from your supporting resources, your assets, your index, your cache. It helps you to manage backups and restores a lot easier. So these assets, so you've got a lot of content in a website, content versus files. Content objects are in the database. It's text in a database. The assets in the file store are a slightly different case. We store metadata about them as content objects in the database, but the files themselves, PDFs, movies, JPEGs, CSS files, Velocity template files, JavaScript files, we don't store those in the database because it's not efficient to do that. So we store them in this asset store. So if you move your site to a new server and you don't move the file assets, or you don't mount an NFS share properly, you go into your website here, you're going to see all of these images are going to be broken. Your style sheet's not going to be working properly. Your velocity, you'll see a lot of question mark or $sign VTL code because your index can't find these objects that it needs. So if we and this is where the assets are located in this situation I have set up, because I have a cluster here. I have 2 nodes in my cluster. They're on this NFS share. This NFS share is actually on the same server as my database, which is not an unusual configuration, where you'll have a database / asset file store all located together. And again, that makes enterprise backups a little bit easier. But if we go dive into these folders, we're going to see a bunch of PNG files, a bunch of CSS, VTL files that are all the code that go into rendering these pages. And the VTL files are they're the velocity templating files that your developers are going to use and your designers are going to use to define functionality and layout of the application server. So that's what the assets are used for. Database obviously is for all of your textual data. The index component is where we store all of our immediate access to content, and where we define what content is live, what content is not live. We use Elasticsearch as our indexing engine. It's a very powerful and efficient text organizing engine. We've made a couple of optimizations, a couple of customizations for the way the dotCMS uses it, and I'll have a few points that I'll talk about when I talk about configuration on how to best use it in the environment the dotCMS does. There's different settings you can use that make sense for different situations. We do also have the ability to externalize Elasticsearch. So if you have an Elasticsearch server and you have a team that already is familiar with Elasticsearch and managing it, then there's no need to have a second Elasticsearch instance with dotCMS managing all that. You can simply point to your existing Elasticsearch and have your index managed there instead. The cache, there's actually 2 layers of cache. There actually can be multiple layers of cache. We have a feature called cache chaining, which allows you to specify as many different levels of cache as you want. Out of the box, there are 2 that are active. There is an in-memory cache, which basically manages getting the latest version of your objects from the database, the most popular objects, as people traverse your website and make calls to things. Ideally, we want to get things out of working memory. That's going to be the fastest response time. The second fastest is going to be an on-disk cache. And that on-disk cache is a dictionary lookup. It's a little bit more efficient than going into the database and running queries. So ideally, we want to go in memory to on-disk cache, and then if we have to go to the database, we will. We do try and avoid it whenever possible because those round trips are, can be expensive. So ideally, we'll serve it out of the working memory, and we'll talk a bit about cache tuning because that's a really important part of getting the best performance out of your dotCMS instance. But those are the essential components of a dotCMS installation. As you expand to a clustered environment, it essentially will look the same, except you've got your multiple instances, each with their own local cache, each with their own local index, that are all pointing at the same database and assets. So the way that clustering works in dotCMS, as anyone edits, deletes, saves, creates any content in the back end, every time there is an update, this index gets updated and this cache gets updated. And the index will communicate between the nodes of the cluster, however many nodes there are. Whichever node they happen to be connected to, they'll hit save, they'll hit delete, whatever. That index will then communicate out to the other indexes in the cluster and say, hey, this object is newer. We've updated it, we've deleted it, whatever. So no longer keep that or update the version you have of that in your index. The cache layer works similarly. When the index gets updated, it notifies the cache. The object with this ID has been updated, so delete the one you have and replace it with one from the database next time somebody asks. And also when anyone is making a request for an object from the database that's not in the cache for the first time, the cache will then store a copy of it. Or if it's a binary object, it will restore a reference to it. And at various points in time, either depending on the number of items in the cache or a timeout that's set on the cache, it will eject objects. And we'll talk about that a little bit more when we talk about cache tuning. When you have a cluster, you have a single database, you have a single asset store. This database can be a database cluster. If you need failover, if you need just that level of performance, you can have a database cluster. There has to be a single point of entry to that cluster for dotCMS for optimal performance. You don't want to have multiple different, like you wouldn't want to have one node connected to one database and a different node connected to a different database that are in sync because the risk of your environments getting out of sync is very high in that situation. So that's not a supported approach.